Hello, Assalamu alaikum, everybody. Good afternoon, and welcome to the lecture number 20 of Discrete Math. You should be able to see my screen right about now. Okay, Beth, can you guys see my screen?
Yes, sir.
Yes,
Okay.
sir.
Okay. Sorry, guys, we could not meet last time. I was feeling a bit under the weather. I feel better now. So this is what we were doing. We were doing pigeonhole principle, which is part of the counting section of our course, जिसमें हम sets की cardinalities या sequences का size count करते हैं. And the pigeonhole principle was that if you have more pigeon than the pigeonholes, then there must be a hole which contains more than one pigeons. इसका generalized version है, which says that if you have n pigeons, and then you have okay, what is it? Right. Yeah, so if you have n pigeons and you have k holes, then there must be a hole which contains a ceiling of n over k pigeons. Okay, so this is sort of a generalized version, which is sort of quite intuitive. Okay, क्योंकि n over k becomes your average, which is the average number of pigeons per pigeonhole. So there must be a hole which contains at least the average number of pigeons. Okay. इसको अब दूसरे एंगल से भी देख सकते हैं कि there must be a hole which is at most the average number of pigeons. Okay. So just to give you an example of what I'm saying, let's say कि आपके पास 10 pigeons and there are 5 pigeonholes. तो फिर however you place them, the average number of pigeons per hole is 2. Okay, and that's the, is this what it is? Yeah, so average number of pigeons per pigeonhole is 2, which means that there must be a pigeon which contains at least 2 pigeons. Okay, but it also means the other way around. It also means that there must be a pigeon which a pigeonhole which contains at most 2 pigeons. Okay, is this clear to everyone? ये मैंने शायद आपको last time नहीं बताया था, but it's not part of this this counting series, but it's in general an averaging argument which is used in counting in combinatorics, that there must be some वैल्यू इन अ सीरीज. अगर आपके पास एक सीरीज है, उसमें उसका आपके पास एक एवरेज है, तो उस सीरीज में एक वैल्यू ऐसी ज़रूर होगी जो कम से कम एवरेज के इक्वल है, और एक वैल्यू ऐसी भी ज़रूर होगी जो एट मोस्ट ज़्यादा से ज़्यादा एवरेज के इक्वल है. ओके, तो द आर्गुमेंट वर्क्स बोथ ways. Alright, today the plan is to do some examples of pigeonhole principle. Pigeonhole principle, जैसे मैंने आपको last time बताया था, it's used very effectively in very active research. Okay, बहुत non-trivial किस्म की statements होती हैं which you look at and you find them not very intuitive. Okay, but somehow pigeonhole principle helps you drive proofs for those statements. कोई questions तो नहीं है before we dig into these examples on pigeonhole principle or generalized pigeonhole principle? Are we good? All right.
Yes, sir.
Okay.
Yes, sir.
Okay. Great. My pen is for some reason not working. Okay, just give me a second. Let me try to replug this thing. Okay. I think maybe this has something to do with the. Let me use a different board. So हम आज कुछ examples देखेंगे. Some of them are from your book, some of them are not from your book, and we'll try to solve these. Okay, so let me move to the first example so that you can read it while I try to plug my pen. It's not working. Let me try again. Yeah, okay, now it's working. Sorry. Okay, so here's our first problem, which says that show that among any n plus 1 positive integers not exceeding to n, there must be an integer that divides one of the other integers. Okay. First of all, does everyone understand the statement of this problem? So you have n plus 1 integers. Let's call them, I think we have some space here. Where's my highlighter? So let's call them, I don't know, a1, a2, a3, an plus 1. Okay, so this is the set of positive integers that I have. And the information I'm given is that these are positive integers, okay, which means that ai is at least 1. Okay, and the second information I have is that it's at most 2n, okay, less than equal to 2n. And the conclusion I want to draw is that there exists some I not equal to j such that ai divides aj. Okay. Is there someone who is not comfortable with the statement of the problem?
सर ये 2n वाले की समझ नहीं आई.
2n वाले की. So it says that every integer is a positive integer, okay, and it's not exceeding 2n. इसकी जो value है, it's not more than 2n. Numbers होते हैं ना, so numbers are between, I don't know, positive integers ऐसे होते हैं ना, 1 2 3 4 5 up to let's say 2n, okay, where n is some fixed number. तो इस range के अंदर से उसने ये n plus 1 numbers pick किए. Let's call it a set. Okay. इस रेंज के अंदर से ना हमने ये पिक किए. ये इनमें से every one of them is coming from here. Yes, no?
Yes, sir.
All right. Okay. So we have these integers and they are coming from this range. And we need to show that there is one which divides another. All right. Begin, people. Ideas. How would you show this? This is actually a tricky question. I don't know why is this one first example, but this is a bit tricky, I think. It's not so easy. Okay. कोई अगर किसी के पास ideas हैं तो now is the time. Now is the time to shine.
सर अज्यूम करें कि अगर हमने n लिए हैं
क्या?
तो वर्स्ट केस में अगर हम 2n की तरफ जाते हैं तो जितने नंबर होंगे 2n से पहले वाले n,
Yeah.
वही सिर्फ उसे डिवाइड नहीं कर सकते.
वो डिवाइड नहीं कर सकते. ओके.
n से नीचे जितने होंगे वो सारे डिवाइड कर देंगे 2n को. उनमें से कोई ना कोई जरूर कर देगा.
कैसे? Why?
2n जो है वो मल्टीपल है n का, तो n तो
Yes.
उसे लाजमी डिवाइड करेगा. n से
हाँ.
आगे जो भी करेंगे हम तो वो डिवाइड नहीं कर पाएगा 2n को.
हाँ, लेकिन हो सकता है कि n ना हो इन नंबर में से. हमें ये तो नहीं पता कि ये कौन कौन से नंबर्स हैं.
लेकिन +1 जो है वो कर देगा कन्फिगर के हमारे पास जो है वो n हो सकता है या n से छोटा होगा.
ओके, दोबारा रिफ्रेश करो. So देखो, each one of these numbers are coming from this range, so it does not, I mean you're not sure कि इसमें से 2 है या नहीं है, you're not sure कि 3 है या नहीं है, you're not sure कि 2n भी है या नहीं है. Okay, particular integers के बारे में you are not sure कि which one. At least half of them तो है. Actually more than half of them. Okay. n+1 integers हैं. Okay. Which means I don't know what does it mean. It means that जो पहले आपके पास n integers हैं उसमें से कम एक integer जरूर होगा आपके पास. And so is true about the last n integers. But
सर
yeah,
ये इंटीजर सेम भी हो सकते हैं इनमें से?
yeah, sure. सेम हो जाएंगे तो लाइफ बहुत इजी हो जाएगी ना. सेम हो जाएंगे तो फिर वो जो सेम इंटीजर होगा वो अपने आप को डिवाइड कर देगा ना.
तो इसमें वी कैन से कि वी कैन नॉट चूज वन फर्स्ट ऑफ ऑल, क्योंकि अगर वन चूज किया तो बाकी सारे
Makes
उससे
sense.
डिवाइड होंगे.
Perfect. Yeah.
Then we can say that we cannot choose two because if we choose two तो कोई और इवन नंबर हम चूज करेंगे तो वो भी डिवाइड हो जाएगा.
That's good. Yeah.
So when we have 2n numbers, 1 to 2n numbers, and we are choosing n+1, so
Yeah.
one of them must be either 2 or it must be 1.
No, it's why? There are a lot of numbers there. There are one over. तुमने कहा कि one नहीं हो सकता. I agree with you. One नहीं हो सकता. Two भी नहीं हो सकता. That makes perfect sense. लेकिन अभी you have still 2n-2 numbers remaining, right? That's a huge set of numbers. If you have to choose only n+1. So, for example, if you have 100 numbers to choose, sorry, if n is 100, so you have how many? 198 numbers left to choose, and you have to choose 101 numbers, right? This is still a very huge set. Yeah, one or two आपने discard कर दिया कि they can't be there. Yeah. Good start, guys. I think not bad. Is there anyone else with an idea? But the JISCA solution, it's actually slightly tricky. It uses modulo arithmetic, जो हमने I don't know few lectures back पढ़ी थी. So here is the solution. The solution says that let me write every integer in this range as this, as power of 2, whatever it becomes, I don't know, xi, let's call it xi. Let me go to a new page. Sorry. So what I'm going to do is that, so I have these, this set, a is equal to a1, a2. I'm assuming it's a set, क्योंकि if it's not a set, it's a multi-set. तो उस केस में we are very fine. जो दो एक दूसरे के equal हैं वो एक दूसरे को divide कर रहे होंगे. Okay, so I can assume that they are unique, which means that this is a set. Okay, now what we are going to do is we are going to write ai as 2 to the power xi times yj, where yj is an odd number. Okay, first question is it possible? Can I always write a number in this form where xi is at least 0 and yj is at least 1, because yj is a positive integer number, positive odd number. Oh, so the first question is that I want you guys to answer. Is it possible? Can I always write an integer as product of an odd number times 2 to the power something?
Yes, sir. You can.
Yes, sir.
Okay, why can I always write it like this?
Because like 2 to the power 0 makes it 1.
Yeah.
So you can cater all the odd numbers, and if you take 2 to the power 1 or any of the other powers, you can cater all the even numbers.
Yeah, perfect. Awesome. So the thing is, if ai is an odd number, I can choose xi to be 0 and this thing will become 1. Or then I can choose yj to be equal to ai. Okay, so इस तरह I can write every odd number as 2 to the power 0 times that odd number. Okay, but if ai is an even number, so here what I do is I divide ai by 2 to get a new number. and check if it's an odd number. If it's an odd number, I can write it as 2 to the power 1 times ai over 2, which was an odd number. Okay, but if it's not, what I can do is I can divide it once more. Okay, जो कुछ आया है उसको एक दो फिर 2 से डिवाइड करूंगा और चेक करूंगा कि वो ऑड है या नहीं है. I'll keep doing it until I either reach an odd number which is more than 1, or I reach 1. Okay, in which case a to the ai is actually something some power of 2. Okay, and then in that case it would be ai would be equal to 2 to the power log of ai times 1. Okay, so I can always, the answer is yes here, I can always write an integer in this form. Is everyone okay with the answer? Yes? Koi confused hai?
Yes, sir.
कोई क्वेश्चन है तो बोल दे. दिस इज द टाइम.
सर समझ में मुझे आया कि 1 और 2 को हमने नेग्लेक्ट किया, वो एक बता दें दोबारा क्यों किए.
1 और 2 को निगलेक्ट क्यों किया है? एक्चुअली इस आंसर के लिए डज नॉट मैटर कि 1 और 2 को निगलेक्ट क्यों किया है. ओके, बट आई विल कम बैक. मैं उस स्लाइड पे जाता हूं तो आई विल शो इट टू यू कि हमने निगलेक्ट क्यों किया है. ओके, अभी हमने लेट्स अस्यूम करो कि निगलेक्ट नहीं किया. ओके
ओके सर.
ऑलराइट. ओके, सो अब हमने क्या किया, अब हमने हर नंबर को इस फॉर्म में लिख दिया. ओके, सो अब मेरा जो ए का सेट है ना, इट्स रिटन एज 2 to the power x1 times y1, 2 to the power x2 times y2, 2 to the power x3 times y3, and so on. Okay, 2 to the power x n plus 1 y n plus 1. All right, so there are a couple of things to note. First thing to note is that all of these yi's must be less than or equal to 2n. Yes, since all of these numbers are actually less than 2 to the n, so they cannot be written as a product which is more than as integers where one of them is more than 2 to the n. Okay, so ये yj ai से तो बड़ा नहीं हो सकता, right? So yi is definitely less than, actually it's less than 2n minus 1, and because it's an odd number. Okay, do you guys agree with this observation that yi can't be really big?
Yes, sir.
Yeah. And secondly, I know that yi must be at least 1, right? Because I imposed this restriction myself. All right. मेरे हिसाब से प्रूफ कंप्लीट हो गया. एक पंच लाइन रहती है, वो कौन बताएगा? Yes? Oh, this was supposed to be easy. Anas, Mateen,
Sir, I don't think.
Ayman, गुलाम मुस्तफ़ा.
सर इवन
क्या?
नंबर के बारे में तो ये था कि 2 का मल्टीपल है तो इवन तो हो जाएगा आई गेस. ऑड का आई कांट रियली गेट इट.
Okay, so here's the thing. मैंने ये कहा कि I wrote my numbers as 2 to the power xi times yj. Okay, और मैंने ये कहा कि for each one of them I know that yi is at least 1 and at most 2n minus 1. Okay, it's an odd number which lies in this range. Okay. Is it an enough clue? Question is, how many odd numbers are in this range? इस range में कितने odd numbers होते हैं? 1 से लेके 2n तक कितने odd numbers होंगे?
Sir,
2n by 2.
Yeah, there are there are there are n odd numbers. Yes.
Yes, sir.
There
Yes, sir.
are n odd numbers in this range. Okay? How many
Yes,
yi's
sir.
we have here?
n+1.
We have n plus 1 yi's here.
Pigeonhole
So,
principle. Oh yes.
so these are our pigeons, and this is the
Okay,
set
okay.
of our pigeonholes. So we are sending here, which means कि यहाँ पे दो yi's ऐसे जरूर हैं जो एक दूसरे के equal होंगे.
बोलोगे.
Okay, one more time. I wrote my set as some power of 2 times an odd number. These odd numbers are coming from the range between 1 and 2n. इस range के अंदर जो total number of odd numbers है वो n है. Okay, and I have n plus 1 yi's, which means कि since all of them are coming from this range, कम से कम दो ऐसे जरूर होंगे जिनकी वैल्यू इक्वल है. Does everyone agree with this conclusion?
Yes, sir.
Yes, sir.
Okay, okay, awesome. ठीक है. So what? उसके बाद क्या होगा? अभी भी मेरे ख्याल में एक आधी सी पंच लाइन रहती है. So इसका मतलब ये है कि मेरे पास यहाँ पे दो इंटीजर्स हैं. Let's call them ai, which is equal to 2 to the power xi times yj, I don't know. और दूसरा है मेरे पास aj, which is 2 to the power xi times yj. Okay? और ये दोनों मुझे पता है कि बराबर है. ये डिफरेंट हो सकते हैं. Okay? Now what?
सर 2 का
तो
एक
हम कह सकते
मल्टीपल
हैं कि ये
दूसरे का
मल्टीपल्स हैं
डिवीजन
because
जरूर होगा.
we can make one by multiplying some power of 2 to the other.
Yeah. So since so the claim is that if ai is less than aj, तो फिर ai definitely divides aj. Okay, because ai is I can get aj by multiplying something with ai. Okay, so some power of 2. All right, so basically, okay, let me do it for you. So it's aj is 2 to the power xj times yj, or ai is 2 to the power xi times yj. ये cancel हो जाएगा and I'm left with 2 to the power xj minus xi. Okay, और ये दोनों integers हैं, तो इसका मतलब ये है कि ये जो चीज़ है ना, ये भी एक integer है. Okay, which means that xi divides xj. Okay, so this proves that in इस range में अगर आप n plus 1 integers लेंगे तो one of them divides another. Okay, let me, so देखो, the tricky part, the only tricky part was this, that you need to somehow figure out how to represent these numbers. Okay, if you know ये वाला step अगर आपको पता है तो उससे आगे you apply the pigeonhole principle and then you are done. Okay, so I wrote my numbers as 2 to the power xi times yj, where yj is an odd number. I know that the number of odd things in this range is n, and I'm choosing n plus 1 of them, which means that two of them must be equal. If two of them are equal, then one ai divides the other aj, for which yj is equal. Okay, and this completes the proof. Questions? And here मैंने ये कहा था कि this can't be one. देखो, क्योंकि one divides everything ना, one के अलावा अगर आपने कुछ भी उठाया यहाँ से तो फिर one must be able to divide it. Okay, तो हम rule out कर देते हैं कि one नहीं हो सकता. One है तो फिर we are done. Similarly, अब one तो है नहीं, अब let's say कि two अगर आप कर लेते हैं तो बाकी जो आपके पास चीजें बच गई हैं उसमें आपके पास जो number of odd things है वो n-1 है. ओके, 3 से आगे अगर आप चले जाए तो ऑड नंबर्स आपके पास n-1 रह जाते हैं. इसका मतलब है आपको कोई एक इवन नंबर लेना पड़ेगा. अगर आप इवन नंबर ले लेते हैं तो इवन नंबर 2 से डिवाइड हो जाएगा. ओके, तो उस केस में भी वी आर डन, व्हिच मींस कि वी कांट हैव 1, वी कांट हैव 2, दैट्स फॉर श्योर, बट इट डज नॉट हेल्प अस सॉल्व द प्रॉब्लम. You can't continue this logic with 3, 4 and so on. Okay, it becomes really complex. But this is, I don't know, quite simple. You just need a different representation, then you need a pigeonhole principle, and then you are done. All right, questions, people?